Welcome to MCP versus API, connecting AI to the real world. This is the paradigm shift from static software integrations to dynamic AI agentic workflows. Today, we face a major integration crisis. Traditional API require hard-coded logic for every single connection. It is a scaling nightmare. Connecting just 2 apps to 10 services means building 20 separate code bases. On top of that, stuffing massive open API specifications directly into an LLM's prompt completely bloats its context and degrades its reasoning. Simply put, APIs were built for deterministic, program-to-program execution. They fail when probabilistic models try to reason over messy, real-world data. Let us establish a baseline. Think of a traditional API as a restaurant waiter. The client application places a highly specific order, like, give me the current weather for New York. The waiter fetches that exact data and returns a rigid payload, usually in JSON or XML. But here is the catch. The waiter has zero autonomy. It does not know why you wanted that weather or what you will do next. You, the developer, are entirely responsible for writing the logic to handle that data. And if that waiter's menu changes, your entire system breaks. Now, enter the Model Context Protocol, or MCP. Think of MCP as the USB-C port for AI. Instead of writing custom adapters, MCP creates a universal connection between models and external data. It turns the transaction on its head. Instead of calling exact endpoints, you give the AI a natural language goal, like, I want to go outdoors. The model dynamically assesses its toolbox, reasons, plans, and chains tools together to make that goal happen. No custom integration code required. Architecturally, MCP operates on 3 distinct layers. First, we have the host. This is the runtime environment, like Cursor or Claude, where the AI lives. Second is the client. It opens standardized, secure sessions over standard input-output, or HTTP. And third is the MCP server. It sits right next to your files, databases, or services, exposing 3 foundational primitives: tools, which are callable functions; resources, which are read-only data files; and prompt templates, which guide how the model interacts with your systems. Let us put them side by side. Traditional APIs are designed for human developers to manually code. MCP is designed for AI models to autonomously act. While APIs rely on static, external documents like open API specifications, MCP servers feature a live, self-describing, dynamic runtime catalog. The interaction shifts from rigid, instruction-based endpoints to goal-based, adaptive reasoning over tools. Ultimately, the developer no longer has to hard-code the execution sequence. The model dynamically plans and chains steps at runtime. Now, let us clear up some hype. MCP does not replace APIs. Traditional APIs remain the foundational plumbing of your backend. They run the databases, execute transactions, and enforce security. Think of MCP as a semantic adapter layer. It sits directly on top of your battle-tested endpoints, wrapping them in an AI-friendly interface. For example, the official GitHub MCP server does not rewrite GitHub's codebase. It simply translates the model's tool requests into native REST API calls under the hood. Here is a critical warning for developers. Your API is not an MCP tool. Naively auto-generating MCP servers from massive open API schemas is a recipe for disaster. It floods the model with too many choices, causing decision paralysis and extreme token bloat. Instead, you must build for workflows. Write direct, action-oriented descriptions using explicit syntax. Look at how Neon does it. Instead of exposing raw database endpoints, they expose a staged migration pipeline, letting the model stage a change, test the SQL, and then call a separate tool to commit it safely. Moving probabilistic models into production requires strict guardrails. First, protect your context window. Implement gateways to dynamically search and load only the specific tools needed for a given task. Second, never give an AI unmitigated write access. Build strict permission scopes and require a human in the loop to approve any destructive actions. Third, keep credentials safely isolated. The model should never see raw secrets. Finally, run robust automated evaluations thousands of times to optimize your tool descriptions and guarantee the model selects the right tool every single time. We are standing at the edge of a massive shift. We are moving from building software strictly for humans to designing systems explicitly for model orchestration. Just as HTTP unified fragmented protocols like FTP and Gopher to create the modern web, MCP is unifying fragmented tools into a single, global, plug-and-play standard. By moving past fragile custom connections, we are finally unlocking true autonomy and empowering AI agents to seamlessly navigate and coordinate our digital world.